Hello and welcome to our discussion of tree diagrams and the fundamental counting principle. Today we're going to be covering two standards having to do with using tree diagrams and applying the fundamental counting principle to determine the number of outcomes in a problem situation. So for a tree diagram we're going to do first, here's a sample problem that you might encounter. You're getting dressed one morning when you realize you have some choices to make. You have 2 shirts to choose from, 3 pairs of pants, and 3 pairs of shoes. Ignoring any color combination, coordination, or fashion, construct a tree diagram to show how many different outfits you could assemble. So here we have our 2 shirts, and we're going to get, for each shirt, we have a possible to get each pair of pants. So here we've got the blue shirt with our 1 pair of jeans, our black pants, and our other pants. And again, with the t-shirt, we could have either of those 3 pairs of pants. And for each of those color combinations, so we have blue shirt, jeans, we could have any of 3 pairs of shoes. So here's our 3 shoes, and for blue shirt and black pants we could also have those 3 shoes. And again, for blue shirt and our last 3rd pair of pants, we can have any of those 3 shoes. So you can see how these tree diagrams are going to get large in a hurry. So here, each pair of pants going to, so if we go from our shirt to our pants there, and from our pants we have the choice of any of those 3 pairs of shoes. So here's where it starts to kind of look like a tree. So here we have our blue shirt with our black pants, and we could do our red shoes, we could do our black sneakers, or our Converse. And blue shirt with our 3rd pair of pants, and there we go. And then again with our t-shirt we have 3 choices, and with each pair of pants we could select any of the 3 pairs of shoes. So here are our branches of our tree, and the end result here is going to give us the number of possible combinations. So if we count at the end, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 possible outfit combinations between 2 shirts, 3 pants, and 3 shoes. Alright, so now we're going to look at a similar problem and just a little definition of what exactly is the fundamental counting principle. Okay, the fundamental counting principle states that if one event has m possible outcomes and a second independent event has n possible outcomes, then there are m times n total possible outcomes. Now, in our previous example, we had 2 shirts, 3 pairs of pants, and 3 pairs of shoes. Okay, so we have 3 independent events. Okay, we select a shirt and we're not caring about fashion, so we just pick up any old shirt and we pick up any old pants and any pair of shoes, and out of those possible combinations we're going to have two times 3. So we had 2 shirts times 3 pants times 3 shoes, and let's see what we get. 2 times 3 is 6, and 6 times 3 is 18. So this matches exactly with our previous example of 18 outcomes. It's just a little bit of a shortcut so that you don't have to construct an entire tree diagram, because if you start getting more than about 18 choices, you're going to make a mess on your paper. All right, now your turn to try. Okay, you're taking your friends to get ice cream. There are 10 flavors of ice cream, 3 kinds of cones, and 15 toppings. How many possible combinations are available? I want you to think about which method you would use to solve this and why you would choose that method. So remember, we have 2 choices, the tree diagram or the fundamental counting principle. So pause your video for just a moment, and when you're ready, click ahead and you'll find the answer. Alright, so you probably got this right. Altogether we have 10 times 3 times 15 combinations, which is a total of 450 possible combinations. Okay, that's a lot of choices. So I'm going to guess and hope that you use the fundamental counting principle. It is certainly much easier than making a tree diagram, because we don't want to have to make a tree diagram of 450 possible outcomes. Alright, now it's your turn to try some more problems. So please download the practice sheet and demonstrate your understanding of both tree diagrams and the fundamental counting principle. And when you're done, make sure you check your answers against the answer key. That will help you determine if you understand the material or if maybe you need to do a little more practice or rewatch the video. Thanks.